Dear students, today's topic is Bohr's theory of hydrogen atom. In this topic, we are going to study an expression for the velocity of the electron, an expression for the radius of the permitted orbits, and also an expression for the energy of the electron in the orbit. Considering the Bohr's first postulate. The first postulate is Rutherford model. According to this model, an atom consists of a central nucleus carrying a positive charge, and the electrons, they are revolving around the nucleus in certain orbits. And the nucleus contains a protons and neutrons. Protons are positively charged particles, neutrons are no charge, and hence the charge of the nucleus is positive. Generally, if Z is the atomic number, then the charge on the nucleus can be represented as Zd. For example, if a nucleus contains 5 protons, then the charge on the nucleus is 5e. The atomic number means it represents the number of protons present. In the case of hydrogen atom, the nucleus contains a unit positive charge, that is a proton with one electron revolving around it. That is, the hydrogen atom contains one proton and one electron. The electron which is revolving around the nucleus with a velocity v, and m is the mass of the electron and r is the radius of the orbit. Then the electrostatic force exerted by the nucleus on the electron supplies the centripetal force for the electron to make the circular motion. Let m be the mass of the electron and v the velocity of the electron and r is the radius of the orbit. Then the centripetal force mv square by r is equal to the electrostatic force 1 by 4 pi epsilon 0 e square by r square. And from this equation, this r and this r will cancel, and the resultant equation is mv square r is equal to 1 by 4 pi epsilon 0 into e square. Considering the Bohr second postulates, that is the angular momentum is quantized. The angular momentum L is equal to nh divided by 2 pi, or the angular momentum can be represented as mvr. It is equal to nh by 2 pi, where n is called the principal quantum number. And next is an expression for the velocity of the electron. And considering the equation mv square r is equal to 1 by 4 pi epsilon 0 e square. That is, mv square r is equal to 1 by 4 pi epsilon 0 into e square. And we have the equation L is equal to, or mvr is equal to nh by 2 pi. And considering these two equations as the first equation and second equation, therefore this equation 1 by 2 will give, that is, mv square r divided by mvr is equal to 1 by 4 pi epsilon 0 e square divided by nh divided by 2 pi. This is equation 1 by 2. Here the mvr and mvr will cancel. Finally, v is equal to 1 by 4 pi epsilon 0 this e square divided by nh divided by 2 pi. This is the equation, that is, velocity v is equal to 1 by 4 pi epsilon 0 e square divided by nh divided by 2 pi. And consider this equation, that is 1 by 4 pi epsilon 0 e square divided by nh by 2 pi. ഈ ഇക്വേഷന് ഒരേ സമയം സി കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യുകയും ഡിവൈഡ് ചെയ്യുകയും ചെയ്യുക. ദാറ്റ് ഈസ്, സി കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യുന്നു, സി കൊണ്ട് ഡിവൈഡ് ചെയ്യുന്നു. അതുകൊണ്ട് തന്നെ ഇതിന്റെ വാല്യൂവിൽ ഡിഫറൻസ് ഒന്നും ഉണ്ടാവുന്നില്ല. ഇവിടെ ഈ മൾട്ടിപ്ലൈ ചെയ്യുന്ന സി കോമൺ ആയിട്ട് ഇങ്ങനെ എടുക്കാം. ദാറ്റ് ഈസ് സി ഡിവൈഡ് ബൈ ഈ എൻ കൺസിഡർ ചെയ്യുന്നു, സി ബൈ എൻ. സി ബൈ എന്നിന് പുറത്തേക്ക് എടുക്കുന്നു. ഇനി ബ്രാക്കറ്റിനകത്ത് ബാക്കിയുള്ള ടേംസ് എടുക്കുക. ദാറ്റ് ഈസ് 1/4πε0 E square divided by hc divided by 2pi. This equation will be hc divided by 2pi. That is c by n into 1/4πε0 E square divided by hc divided by 2pi. That is the equation. V is equal to c by n into 1/4πε0 E square by hc by 2pi. Consider this term, that is the term in the bracket. That is 1/4πε0 is a constant. Epsilon 0 is 8.85 into 10⁻². Then E, that is the charge of the protons and electrons. It is a constant 1.6 into 10⁻19 coulomb. And the H, the Planck's constant, it is 6.634 into 10⁻34. And C, the velocity of light, it is 3 into 10⁸. These constant can be replaced with another constant, alpha. That is, alpha is known as the fine structure constant, where the value of alpha is 1/4πε0 E square divided by hc by 2pi. And substituting the value of this constant, we get the alpha is 1/137. Therefore, the equation V is equal to c by n into this alpha. That is, velocity V is equal to c by n into alpha, where alpha is equal to 1/4πε0 E square by hc divided by 2pi. It is a dimensionless constant known as fine structure constant. Substituting the numerical values of c, h and e in alpha, it is found that alpha is equal to 1/137. Therefore, generally the velocity of the electron in the nth orbit is V is equal to c by n into alpha. So, considering the electron in the first orbit, that is n is equal to 1. For the first orbit, n equal to 1. Therefore, the velocity V is equal to c by 1 into alpha, or it will be c alpha, or alpha is 1/137. Therefore, the velocity of the electron in the first orbit, it is 1/137 times the velocity of light in vacuum. That is, the electron in the first orbit of the hydrogen atom has 1/137 times the velocity of light in vacuum. Therefore, the general expression for the velocity of an electron in an orbit is V is equal to c by n into alpha, where c is the velocity of light in vacuum and n is the orbit in which the electron is orbiting, and alpha is the fine structure constant. Next is the expression for the radius of the permitted orbits. And consider the Bohr second postulates. That is, the angular momentum is quantized. That is, mvr is equal to nh by 2pi. Here, r will be equal to, r is equal to nh by 2pi divided by mv. Substituting the value of v, that is, v is equal to c by n into alpha. Therefore, r will be equal to n into h divided by 2pi divided by m into v will be c by n into alpha. This n will go to the numerator, then it will be n square divided by m into h divided by 2pi divided by c alpha. That is, r is equal to n square by m into h divided by 2pi divided by c alpha. That is, n square by m into h divided by 2pi divided by c alpha. Substituting the value of m as mass is equal to 9.1 into 10⁻31 kilogram, and h Planck's constant is 6.634 into 10⁻34 joule second, and alpha is 1/137, and the velocity of light c is 3 into 10⁸ meter per second. Then we get finally r is equal to 5.29 into 10⁻11 n square, or it can be written as 0.529 Armstrong into n square. That is, the value of the R is 0.529 Armstrong. That is 529 into 10 raised to minus 10 meter into n square. That is, R will be proportional to n square. Next is the expression for the energy of the electron in the orbit. The energy of the electron in the orbit, stationary orbit, is partly potential and partly kinetic. And from the equation, mv square r is equal to 1 by 4 pi epsilon 0 into e square. mv square is equal to e square divided by 4 pi epsilon 0 r. Therefore, the kinetic energy is half mv square. That is half into e square divided by 4 pi epsilon 0 r. This is the kinetic energy of the electron in a stationary orbit. Potential energy of the electron in the orbit. It is given as minus e square by 4 pi epsilon 0 r. That is, potential energy can be represented in terms of the electrostatic force of attraction between the nucleus and the electron. That is, potential energy can be represented as the force work done. That is, work done is the F dot dr. And also we have studied that the potential energy and force are related as force is equal to minus dV by dr, or the V is equal to potential energy is equal to minus F dot dr. That is the work done. This is the work done. Considering this equation, we get the force or the potential energy is equal to minus F dot dr, and here the force is given as 1 by 4 pi epsilon 0. Considering the two charges, one is the charge on the nucleus, it is plus E, and the charge on the electron is minus E divided by R square. It is the force. Therefore, this force within the limit 0 to R into dr, where R is the radius of the first orbit. And then this equation will get, that is minus 1 by 4 pi epsilon 0 into E into minus E divided by R square into dr. Then it will be 0 to R. 1 by 4 pi epsilon 0 can be taken outside. That is, E square also taken outside. 1 by R for R square dr. Then integral 1 by R square dr is minus 2 plus 1 minus 2 plus 1. Therefore, the final equation will be, this will give R raised to minus 1. This is minus 1. That is minus E square by 4 pi epsilon 0 into 1 by R. This is the value of the potential energy. That is, the potential energy can be represented in terms of the work done, or the potential energy can be represented in terms of the force, or the force is the negative gradient of potential energy. And hence, by considering this electrostatic force, the potential energy can be represented as the potential energy of the electron in the orbit is E square minus E square by 4 pi epsilon 0 R. And considering the total energy of the electron in the nth orbit, that is the sum of kinetic energy plus potential energy. ഒരു ഇലക്ട്രോൺ, ഒരു ഓർബിറ്റിൽ ഇരിക്കുന്ന ഇലക്ട്രോണിന്റെ ടോട്ടൽ എനർജി എന്ന് പറയുന്നത് അതിന്റെ കൈനറ്റിക് എനർജിയും അതിന്റെ പൊട്ടൻഷ്യൽ എനർജിയും കൂടെ കൺസിഡർ ചെയ്യുമ്പോഴാണ്. കൈനറ്റിക് എനർജി എന്ന് പറയുന്നത്, ഒരു ഇലക്ട്രോൺ ഒരു ഓർബിറ്റിൽ റിവോൾവ് ചെയ്യുമ്പോൾ ഇറ്റ് ഹാസ് സം കൈനറ്റിക് എനർജി. ദെൻ ഈ ഇലക്ട്രോൺ ഓർബിറ്റിൽ ഇരിക്കുമ്പോൾ ആ ന്യൂക്ലിയസിലെ പോസിറ്റീവ് ചാർജും ഈ ഇലക്ട്രോൺസും തമ്മിലുള്ള ഇലക്ട്രോസ്റ്റാറ്റിക് ഫോഴ്സ് ഓഫ് അട്രാക്ഷൻ ഉണ്ട്. Because of this electrostatic force of attraction, the energy comes, the potential energy comes. Therefore, the total energy will be the sum of kinetic energy and the potential energy. That is, kinetic energy is half E square by 4 pi epsilon 0 R. and the potential energy is minus E square by 4 pi epsilon 0 r. Then the resultant will be energy of the electron in the nth orbit En is equal to minus half E square by 4 pi epsilon 0 r. Here substituting the value of r, we have already calculated the value of r, that is r is equal to n square h by 2 pi divided by m c alpha. This is the value of r. Substituting the value of r in the denominator, then we get the energy of the electron in the nth orbit En is equal to minus half 1 by 4 pi epsilon 0 E square into mc alpha by n square h by 2 pi. And considering this equation, multiplying and dividing with the c, ഒരേ സമയം c കൊണ്ട് multiply ചെയ്യുകയും divide ചെയ്യുകയും ചെയ്യുക equation, then we get that is half into E square by 4 pi epsilon 0 m c square alpha, multiply ചെയ്യുമ്പോൾ c square alpha എന്ന് കിട്ടുന്നു, divide ചെയ്യുമ്പോൾ hc by 2 pi എന്ന് എഴുതുന്നു, hc by 2 pi into n square. Then equation ഇതൊന്ന് rearrange ചെയ്ത് എഴുതാം, that is half into 1 by mc square alpha divided by n square 1 by 4 pi epsilon 0 E square by hc divided by 2 pi consider ചെയ്യുന്നു. അപ്പോൾ ഈ ടേം നോക്കുക, 1 by 4 pi epsilon 0 E square by hc divided by 2 pi. ഇതിനെയാണ് ആൽഫ എന്ന് പറയുന്നത്, ഫൈൻ സ്ട്രക്ചർ കോൺസ്റ്റന്റ്. അതായത് ഈ ബ്രാക്കറ്റിനകത്ത് ഈ ടേം കൺസിഡർ ചെയ്യുക, this term it will be alpha. Then considering this term as alpha, then we get the energy En is equal to minus half m c square alpha by n square into this will be alpha, that is energy of the electron in the nth orbit En is equal to minus half m c square alpha square by n square. Substituting the value of m, c and alpha, that is m as 9.1 into 10 raised to minus 31 kilogram, c as 3 into 10 raised to 8 meter per second, and alpha as 1 by 136. Then we get the value of the energy of the electron in the nth orbit, and expressing this energy in electron volt, then we get En is equal to minus 13.6 by n square eV. And for the first orbit, n is equal to 1. It means that the energy of the electron in the first orbit E1 is equal to minus 13.6 divided by 1 square. That is E1 is equal to minus 13.6 eV. For the second orbit, that is n is equal to 2, the energy of the electron in the second orbit E2 is equal to minus 13.6 by 2 square. That is minus 13.6 by 4. It is minus 3.4 eV. And for the third orbit, n is equal to 3. Therefore, the energy of the electron in the third orbit E3 is minus 13.6 by 3 square. That is minus 13.6 by 9. It is minus 1.51 eV. That is the energy of the electron in an orbit of an atom is negative. It means that the electron is bound to the nucleus. That is, the greater the value of the negative energy, that is, the greater the value of the negative energy, the greater is the binding force between the nucleus and the electron. That is, for the electron in the first orbit, the energy will be minus 13.6. And for the electron in the second orbit, the energy will be minus 3.4 eV. And for the electron in the third orbit, the energy is minus 1.5 eV. That is, the greater the value of the negative energy, the greater is the binding force between the nucleus and the electron. That is, for the electron in the first orbit, the greater will be the force between the electron and the nucleus. For the electron in the second orbit, the less stronger will be the binding force between the electron and the nucleus. ഇതുപോലെ ഓരോ ഓർബിറ്റിൽ ഇരിക്കുന്ന ഇലക്ട്രോണും അതിനകത്ത് ന്യൂക്ലിയസും തമ്മിലുള്ള ബൈൻഡിങ് ഫോഴ്സിനാണ് ഈ എനർജി റെപ്രസെന്റ് ചെയ്യുന്നത്. അതായത് ഫസ്റ്റ് ഓർബിറ്റിൽ ഇരിക്കുന്ന ഇലക്ട്രോൺ വളരെ സ്ട്രോങ് ആയിട്ട് ബൈൻഡ് ചെയ്തിരിക്കുന്നു ന്യൂക്ലിയസുമായിട്ട്. സെക്കൻഡ് ഓർബിറ്റിൽ ഇരിക്കുന്നത് അതിനേക്കാളും കുറച്ചുകൂടെ ലെസ് സ്ട്രോങ് ആണ്. ദെൻ തേർഡ് ഓർബിറ്റിൽ ഇരിക്കുന്ന അതിനേക്കാളും കുറച്ചുകൂടെ സ്ട്രോങ് കുറവാണ്. അപ്പോൾ ഇങ്ങനെ ഈ എനർജിയുടെ വാല്യൂ ഈ ന്യൂക്ലിയസും ഇലക്ട്രോണും തമ്മിലുള്ള ബൈൻഡിങ് ഫോഴ്സിനെ റെപ്രസെന്റ് ചെയ്യുന്നു. ദാറ്റ് ഈസ് the electron in the first orbit has a maximum negative energy. That means the binding force between the first orbit electron and the nucleus will be maximum. ഇത് ഈ ഔട്ടർ ഓർബിറ്റിലേക്ക് പോകും തോറും ആ ബൈൻഡിങ് ഫോഴ്സ് കുറഞ്ഞുകൊണ്ടിരിക്കുകയാണ്. That is the electron in the outermost of the electron is the electron in the outermost of the orbit is leastly bound to the nucleus. That is അതിന്റെ എനർജി അതുകൊണ്ട് തന്നെ കുറവായിരിക്കും. ഇതാണ് ഈ എനർജി വാല്യൂസ് റെപ്രസെന്റ് ചെയ്യുന്നത്. Significance of negative energy of the electron in an orbit. The energy of an electron in the orbit of an atom is negative. That is, for the hydrogen atom it is minus 13.6 by n square eV, where n is equal to 1, 2, 3, etc. It shows that the electron is bound to the nucleus. The greater the value of the negative energy, the greater is the binding force between the nucleus and the electron. Since the electron in the first orbit has maximum negative energy, the binding energy of the first orbit electron is maximum. That is, the binding force decreases for outer and outer orbits. That is, the electron in the outermost orbit of an atom is least bound to the nucleus. ഒരു ആറ്റത്തിലെ ഒരു ഇലക്ട്രോണിനെ റിലീസ് ചെയ്യാൻ ആവശ്യമായ എനർജി നോക്കിയാൽ ഫസ്റ്റ് ഓർബിറ്റിൽ ഇരിക്കുന്ന ഇലക്ട്രോണിനെ റിലീസ് ചെയ്യണമെങ്കിൽ മിനിമം -13.6 eVക്ക് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള എനർജി കൊടുക്കണം. അതുപോലെ സെക്കൻഡ് ഓർബിറ്റിൽ ഇരിക്കുന്ന ഇലക്ട്രോണിനെ റിലീസ് ചെയ്യാനാണെങ്കിൽ ഏകദേശം -3.4 eVക്ക് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള എനർജി കൊടുത്താൽ മതി. അതേസമയം തേർഡ് ഓർബിറ്റിൽ ഇരിക്കുന്ന ഇലക്ട്രോണിനെ റിലീസ് ചെയ്യാനാണെങ്കിൽ 1.5 eVക്ക് കറസ്പോണ്ടിങ് ആയിട്ടുള്ള എനർജി കൊടുത്താൽ മതി. ദാറ്റ് ഈസ് ആ ഔട്ടർമോസ്റ്റ് ഷെല്ലിലേക്ക് വരുമ്പോഴും ആ കൊടുക്കേണ്ട എനർജി എക്സ്റ്റേണലി റിമൂവ് ചെയ്യാനായിട്ട് ഒരു ഇലക്ട്രോണിന് ഒരു ഓർബിറ്റിൽ നിന്ന് റിമൂവ് ചെയ്യാൻ ആവശ്യമായ എനർജി കുറവായിരിക്കും എന്നുള്ളതാണ്. അതായത് ഇലക്ട്രോൺ ഫസ്റ്റ് ഓർബിറ്റൽ ഇലക്ട്രോൺ വളരെ സ്ട്രോങ് ആയിട്ട് ന്യൂക്ലിയസുമായിട്ട് ബൈൻഡ് ചെയ്തിരിക്കുന്നു. ദെൻ ഔട്ടർമോസ്റ്റിലേക്ക് വരുമ്പോൾ അത് ലെസ് ഓർ ലീസ്റ്റ് ബൗണ്ട് ടു ദ ന്യൂക്ലിയസ്. That is the significance of negative energy of the electron in an orbit.